All right, we are going. So we are going to finish up 11.6 today, and we want to review for your exam on Friday, right? And if you need to, there'll be exam retry on Saturday, which will be in some giant auditorium with all the students from all the classes. Want to take the retry. I forget what the stipulations are on it. I'll put it in an announcement after class today for the retry. I know it's a written assignment instead of like my math lab, and you might have to make a certain. I know you have to have done all your my math lab homework. All right, to be able to take the retry, they're not going to let you take the retry if you didn't do all your homework. So there's stipulations, that allow you to do the retry. But I think you'll all do pretty well on the exam itself. Historically, I only have maybe 5 or 6 students out of a 90 student class that bother to take the retry. Right? And most of them don't do very well because they didn't study for the first exam, right? So we'll finish 11.6 today. There is a practice exam in my math lab, so that's probably what we'll do after we finish this is we'll work the practice exam together. All right. So I think this section only has one more example here. Well, there's a checkpoint. Let's do this checkpoint. Okay. So here we have a cost function. So you remember you have the cost function, you have the average cost function, okay? You have marginal, right? When you see the word marginal, you think prime, and then the marginal average, right? Marginal average, right? So the derivative gives you that marginal. So this one right here, marginal average, you're going to need this guy, okay? So knowing that, so for the average cost for part A, I guess this is cost, this is average, this is your marginal, this is your average marginal. So part A, if this is the cost function, the average cost, which is the cost divided by your input, is x squared plus 2x plus 5 over x plus 1 plus 1,000 divided by x, all right? So if we divide everything by x, we get what? X squared plus 2x plus 5. We multiply everything here by x, we get x squared plus x. And then 1,000 divided by x. I'm just going to write that as x to the minus 1. Okay. So that's part A. Boom. Part B, the marginal average cost function. Okay. Well, if this is our C bar, right? Then C bar prime, we just have to take the derivative of this, right? And okay, so since this guy is a quotient, a fraction, we need to use the quotient rule. Remember, what is the quotient rule? If you have u over v prime, what was it? It was v u prime minus u v prime over v squared, all right? And on the exam, this formula will be given to you. I'll write it on the board, all right? As well as the product rule, okay? Those will be the two formulas that'll be written on the board. You don't have to necessarily memorize them, but I mean, if you're doing your homework and stuff, you're probably going to remember them. All right, so C prime bar. So we need to take the derivative of this thing, right? So let's see. Let's go ahead and write it out. We want the derivative of this whole thing, right? Oops, ddx. So that would be the derivative of this guy plus the derivative of this guy, right? So I'm going to kind of bounce between the ddx notation and the prime notation, right? So for this guy here, let's see, the derivative, we know it's going to end up all over the thing on the bottom squared, right? Copy that. So we had what? The thing on the bottom times the derivative of the thing on top, right? So I'm going to start skipping steps here. What's the derivative of this? The power rule says that would be a 2x plus 2. That's our VU prime. Now minus U B prime. So what's the derivative of this guy down here? It would be 2x plus 1. All right, so that's the derivative of this thing. Now we need the derivative of that. So we multiply by the exponent, so that would give us a minus. Then we subtract 1 from the exponent. Okay, there's your marginal average cost. The rest is just algebra. All right, I'll let y'all do the rest of that. Y'all can do algebra right now, right? Maybe not so well, but you can do it. It's just practice, right? So that's checkpoint. So let's look at this last, the word problem, right? The word problems are where it's at, right? So what we want to do is take this paragraph and dissect it so it just becomes like that checkpoint problem. The cost in hundreds of dollars, don't forget that. I always forget those. Incurred by a flower shop to produce X hundred flower arrangements. So here both the input and the output is in hundreds. Don't want to forget that. It's an easy way to screw things up, right? On a multiple choice test. For delivery on Valentine's Day. Oh, hey, isn't that like tomorrow? Wow, good timing, huh? All right, is given by C of X. So here's our cost function. All right, great. Look at part A. Find the marginal cost. All right, marginal cost. That's C prime. We need to find C prime at 200. Right? So when you see marginal, that's just the derivative, okay? If it's marginal average, you have to do the bar as well, right? Remember, 4 different things going on here. Cost, average cost, marginal cost, and the marginal average cost. That's basically as complex as it's going to get this semester. Those 4 things, okay? All right, so first, do we have the cost? So we just need to find the derivative. So power rule, multiply by the exponent, subtract 1, and then 3. So therefore, C prime at 200, 2 times 200 plus 3 is 403. So what does that mean? It means that, wait, this is in hundreds of dollars. So what does this mean? This 200 is in, wait, hold on. 200 of flower arrangements. So I did this wrong. X is in hundreds, so we just want to put the number 2 there. Screw that up every time. You have to be real careful about that. X is in hundreds, so if we just plug in a 2, right, this means X equals 2. We have 2 times 2 plus 3. That's 4 plus 3 is 7, right? But this, the cost is in hundreds, so this is really $700. So that means the price, the cost to go from 200 to 300 flower arrangements is $700. That's what that means. That makes sense? All right, it's the definition of that word marginal. All right, let's look at the next one. Yeah. Find the average cost. Okay. Well, that means we need to find C bar, which is C over X. So if we divide everything here by X, we get X plus 3 plus 18 over X, right? This is just average. So C bar at 200 would be, dang it, I did it again. 2, that would be a 2 plus 3 plus 18 over 2. 18 over 2 is 9, plus 5 is 14. That's really 1400. All right, so that means if you, the average cost, all right, case per 100, the average cost per 100 flower arrangements is 1400 if you've made 200 flower arrangements. All right, let's think about these. This might be 14. I think this is supposed to be 14. Why is it 14? Why aren't we doing it? Because this is in hundreds, right? Let's look at the units, right? This is in hundreds of dollars, right? And this is per 100 flower arrangements, right? Because they're both in hundreds, we just get dollars. So we don't want to do that here. This is just $14. The average cost per flower arrangement is $14 when you have 200 flower arrangements. Does that make sense? Why we don't want to take this to 1400? Because it's hundreds over hundreds, so those hundreds cancel out. So we don't want to do that here. It's C over X, right? Here's C, right? If I divide everything by X, X squared over X is that, 3X over X is that, and then 18 over X. Does that make sense? Okay. And then we just plug in our 2, we get 14. So that's what that means. The average cost per flower arrangement when you have 200 flower arrangements is $14 per arrangement, right? Because cost is in hundreds of dollars, X is hundreds of arrangements, right? So you end up with dollars per arrangement, right? It's the units that are tough, right? We need to get used to writing the units. Y'all are used to a lot of math problems where you don't have to even write the units down because they're so simple, right? But in reality, it's the units. The first most difficult part is defining your variable. In almost all of these problems, the variable's already defined, right? They tell you X is hundreds of flowers arrangements. That's the hardest part of any word problem, really, in reality, is just what you define your variable, right? The next step is figuring out your units. That's hard, right? So the hard part's usually done for you. All we have to do is just plug the numbers into formulas for the most part in here, right? So we got it easy. Let's look at part C here. I wouldn't do very good on one of y'all's exams because I always mess up the units. I always forget to look at the hundreds and stuff like that. I just go through the math and I get an answer and I forget to like, oh yeah, this is hundreds and that one's in pesos and I'm going to convert this to that. All right, part C, find the marginal average cost. So we need to find marginal average, right? Well, first we need to have the average and then take the derivative. All right, so let's see. Here was our average. All right, this is the one that students will miss the most. All right, marginal average. They won't consider that. They will just take the derivative. They'll just do this one, right? Remember, you have to divide the cost by X. And now we take the derivative of that. I'm going to rewrite this as X to the minus 1 just to make it easier to do the power rule, right? So if we're going to take the derivative of this guy, the slope of X is just 1. Derivative of 3 is 0. This guy, multiply by the exponent, and then subtract 1 from the exponent. So this is just 1 minus 18 over x squared. That's the marginal average cost. They want to find out at 200 and 500. So remember, this is just over. This is just 2, and this is just 5. So at 2, we get a 1 minus 18 over 2 squared. What is this? By the top and the bottom by 2, we get 9 halves. So what is this? This is 1 is 2 halves, right? So this is negative 7 halves, or negative 3.5. Okay. So remember the C bar, this had the hundreds over hundreds, right? So we don't need to change this. This is really negative $3.50. So what does this mean? All right. Marginal average cost. That means when we go from 200 to 300, all right, our average cost goes down by $3.50 per assortment, right? So it's the combination of marginal and average, right? When we go, the marginal was like, if we go from 200 to 300, how much would it cost per arrangement? The marginal, right, and you know what average is, so we need to put those two words together. So when we go from 200 to 300, the average cost goes down by $3.50 per arrangement. That's what that means. The most complicated stuff we're going to do in here. You're going to get this every time. Every time we're going to do, like, we might, instead of cost, it might be profit. We'll do the average profit, the marginal profit, and then the marginal average profit. That's what we're going to do over and over and over and over again. Okay. All right, questions about this one? Okay, let's see if there's a part D. Oh, there is. Oh, and a checkpoint. Okay, find the level of production at which the marginal cost is 0. All right, let's find our formula for marginal average cost, set it equal to 0, and solve for x. Does that make sense? That's what they're saying. When is the marginal cost 0? Let's see, here's our marginal average cost, right? Marginal average. This is our marginal average, right? Let's just use this version of it here. This is our marginal average cost. What level of production is this thing 0? So let's set it equal to 0 and solve. So let me see, if I move the 1 over here, I have 18 over x squared equals 1. Now, I'm going to take the reciprocal of both sides because I don't want the x on the bottom. So if I flip both sides over, 1 over 1 is still 1, right? Okay, great. Now I'll multiply both sides by 18. And now I will take the square root of both sides. And it should be a plus or minus, but we're not interested in negative production levels, right? That's why I only put implies here, not if and only if, right? This implies that, right? I'd have to do this to maintain that these are logically equivalent, but they're not. I'm throwing out a solution, right? I'm only keeping the positive one. So this just implies that. So let's see, 18 is what, 2 times 9. 9 is 3 times 3, right? So I can pull 2 of those out to make 1 outside. So whatever that is, and this is a decimal, right? Let's see, what is this? This is the other part where I quit early. 3 times, let's do the 2 square root button times 3. It's 4.24. All right. So again, this is in hundreds over hundreds, right? So this is just production. So let's see, production is in hundreds, so this is really 424 units, right? Because X is in hundreds. And actually, this is 4.24264 dot dot dot, right? So this is really 424, or is it 425? Because we can't have like 4 2/4, right? 424.264, right? So we need to either round up or round down because you can't have like a quarter of a unit, right? Quarter of a flower. I guess you could have a quarter of a flower arrangement, right? You're like, I couldn't afford a whole egg, so here you go, sweetheart. Yeah. Why did I get rid of the minus sign going here? Is that your question? Well, this is referring to level of production. So we're not talking about like negative flower arrangements, right? That doesn't make any sense. That's why we throw that one out. All right. All right. We have to stick to reality here. So find the level which is marginal average cost is 0. I'm not sure which way they want us to round this, up or down, right? Because y'all are doing my math lab and they'll only accept one answer over the other, right? Yeah. So what do y'all think? Should we round up or down? Which makes more sense? Well, if you're just rounding a number, right, without any context in reality, right, you would round down. But here we have to round based on the context of our reality, not just a rule in math, right? Because the rule in math here says that you get plus and minus there, right? But based on reality, one of them doesn't make sense. So we have to use our common sense here. Well, let's see, going down. You cannot make a negative number of flower arrangements. So X is 4.24. All right, and that's an approximation. So they just rounded to, yeah, they rounded down. The production of 424 flower arrangements will yield a marginal average cost of $0. Then they rounded down because you can't make a whole nother one. If we round it up, then yeah, we'd be off. So you want to round down there. Yeah. 424 arrangements. No, on the test you throw away the minus because you're trying to answer this question. Now, if the test is just, well, if they're talking about an average cost, even generically, you'd still throw away the negative one. All right. But if they're doing something like this, see this one, there's no words, right? Except for, but they do say it's a cost function. So for something like that, you would still throw away the minus. Now, if they just say a function and we're just talking about pure math, then you'd want both of them. But everything y'all doing here is applied in the business sense, right? So you have to be careful, like read the question carefully. But for the most part, almost all your problems are going to be, word problems with meaning. So that's it for 11.6. If y'all have any questions from your My Math Lab, I will answer them. So we have the rest of today and then Wednesday, all right, to do whatever we want. Let's see here. We can look at the practice test and work that together. That might be the best way to prepare y'all. How do I make this work? Manage. practice test. I'm assuming they're the same. There's two of them, one that's timed and one that's untimed. Preview. Right. Well, well, what happened, man? Where'd it go? Oh, there it is. Find the domain, right? Well, the domain is only the numbers you can plug in where you get something back, right? Obviously, you can't divide by 0, so x cannot be a positive or negative 7, right? And that's probably not that's not one of the answers, right? Because this is what the domain isn't. We need to say what it is. So in interval notation, we'd say everything from negative infinity to negative 7, then everything from negative 7 to 7, then everything from 7 to infinity. That's how you want to write that in interval notation, right? Oh yeah, this one. See, they want an integer or a decimal here. All right. What? Here's a function. It's a piecewise defined function. Find f of 5. All right. Well, we have to use this guy because it says use this one if x is bigger than or equal to 2. So it could be 5 times 5 minus 9. Right? If we use that guy, it would be 25 minus 9 is 16. F of minus 2. Well, negative 2, we have to use that one because x is less than 2. So this would be minus 2 squared, which gives us 4. F of 2.6, 2.6 lies here, so we would have 5 times 2.6 minus 9, which is, I don't know, some number, right? And f of negative 0.4, negative 0.4 is less than 2, so this would be negative 0.4 squared. Whatever, plug that in your calculator. Yes. What? This? It's 2.6, right? When I'm doing my math, like for myself, this is the number 2. This is the number 7, right? And when I'm presenting this stuff as fast as I can, and it should be obvious that it's a 2.6, right? I'm writing quickly, right? When I do my math for myself and I don't want to make a simple mistake that's going to like wreck the next 45 minutes of my math problem, I write everything very clearly, right? I have several different ways of writing the letter X, right? Here's my number 1, always, all right? And I recommend that you adopt these things. It sucks that they're getting rid of cursive in school, you know? It's like you can't do math without cursive. You can't do physics. You can't do science. I mean, without cursive, well, yeah, you can text message really well, but you're totally getting screwed, right? You need to be able to write the letter X at least 10 different ways if you're going to do any kind of like science, you know? We run out of letters. So yeah, this, you'll never mistake that for a 7, right? You'll never mistake that for a 1, right? The letter T is always that, so I don't want to mistake it for a plus sign, right? L is always the cursive L, because otherwise it looks just like a 1, right? These are important things, you know. You know, they say you're right brain to your left brain, right? Either you're good at math or you're good at art. They're the same damn thing. I mean, how many people walk around like, you know, half brain? That'd be dim-witted, wouldn't it? You know, you can't do math unless you're good at art, you know, and your art's gonna suck unless you're decent with a mathematical mind, you know. You have the most boring art ever. I mean, anybody could do art, right? Everything's art. Don't let me start making fun of musicians. You know how like you get a song that you really like, you know, but after you've heard it like a whole lot, it's just like, oh, that's so irritating, right? That's all music for me. You know, it's like unless I'm really drunk, it's like I don't want to hear the music. It's just the same information over and over and over and over and over. Just like once I've heard like the first rhythm, it's like, okay, I've heard your whole song. I don't want to hear any more of it. It's annoying. Some you grow out of, you know. Again, unless I'm really drunk, then the worst karaoke bar sounds great. All right, let's look at question 3. Yes, I don't care. I still don't care. It still didn't give me the next question. Give me question 3. Fart. I have to just gonna. Yes, I want to leave this question. I cannot do it. Bastards. But I'll put just weird stuff in here. That's just so lame. Okay. The difference quotient. What is a difference quotient? Right? This is the difference quotient, right? Difference quotient. This is basically your slope, right? It's your change in y over your change in x, but specifically, right? It's where your change in x is x plus a little bit, right? The h is like a little bit that we eventually let go to, we take it to 0. So this is your change in y, this is your change in x, right? H, this is really x, uh, x plus h minus x, right? The difference in the x values, those go away, and that's why you're just left with h. That is your change in h, I mean change in x, okay? So they give you the difference quotient. What is it? Well, all we have to do is plug in our function here. So f of x plus h, just replace x with x plus h. Then we have minus f of x. Well, here's f of x, and then all over h. The big mistake students will make is they won't put the parentheses there, okay? We're subtracting all of f of x. This is all of f of x. We need to subtract the whole thing. You have to have the parentheses there. This part here, stump students, this is our function. It says square the input and add 4. Here's our input. Square the whole input and add 4, right? This is stuff from like day 1 of algebra 0 class. Then that's all they want you to do. I mean, the rest of it, I guess they want you to like multiply it out and stuff. Is this a, this is a type it in kind of thing. So square this, you get x squared plus 2xh plus h squared. Remember, x plus h squared is not x squared plus h squared, right? Basic algebra stuff. You get the cross terms. Then we have minus x squared and then a minus 4 all over h. And then, oh, those cancel. So we get what? 2xh plus h squared minus 4 over h. That's your difference quotient. Yes. Oh yeah, I forgot this 4 here. Plus 4. Yeah, thank you. Thought it looked weird. So now we could reduce the h's, right? So we get a 2x plus h. There's our difference quotient. Questions? All right. Difference quotient is 1. I'll put This is number 3, 4. 1, 2, 3, 4. Thank you. The revenue in millions of dollars from the sale of X units of home supply outlet is given by R of X. The profit in millions of dollars is given by P of X. Find the cost equation. Okay, well, the cost equation, right? Profit is what? Revenue minus cost. So they give us revenue, and then we need to subtract, wait, what are we looking for? Cost? Oh. So profit is revenue minus cost. The cost is revenue minus profit, right? Move that over here, move that over there. Yeah, revenue minus profit. Make sense? Yeah. So we just plug this in. There's our revenue, and then subtract our profit. Right? Again, have to have your parentheses. You can distribute this minus. Let's see, what is it? 0.08. Use my calculator so I don't screw up my limits. It's 0.23 minus 0.086 is 0.144x minus makes a plus 0.7. That's the cost function. That's part A. Find the cost. The cost of producing 5 units is, and look, they already have the word million here. All right, so we don't have to convert to millions. So sometimes they'll have it here and sometimes they won't. So you have to pay attention, okay? You don't want to get the whole thing wrong because you didn't look at that. So you just place 5 in here. 0.0144 times 5 is 0.7, right? The X units, X is just X units, okay? They didn't mess with the input there. They didn't say X is in millions or halves or anything, right? So just plug that in your calculator. The break-even point occurs when how many units are sold? Well, when is the break-even? The break-even is when revenue is equal to cost, right? It's when your profit is 0, right? So we just set these equal to one another. So revenue is equal to cost. So this is a simple linear thing. We'll let's see if I subtract this from that, I get what? 0.144x plus 0.7 equals, well, I didn't need to do that, equals negative 0.7. So all I did was subtract that from both sides. So now divide both sides by this guy. So 0.7 divided by 0.144. Either negative 4.86. That doesn't make any sense. We shouldn't have a negative, right? That doesn't make sense, negative units. So what am I doing wrong here? Right? It happens when the profit is 0. That happens when revenue is equal to cost. Let's see, here's the revenue. Here's the cost. 0.23 minus 0.086 is equal to that. So X is negative point. The break-even point. What am I missing here? We can't get a negative units, right? That doesn't make any sense. Let's think about it. Let's see, this revenue here, right? We're making 23 cents per unit. So revenue is simply like, right, at 0. So revenue looks like this. This guy starts out down here at like negative 0.7, and then it goes up, right, with a slope of 0.086. This guy has a slope of 0.23, right? That's about a slope of 1/4, right? So for every one I go up, I go to the right 4. This slope is 0.086. That's less than a tenth. So the profit here, oh, I see. I'm using profit as cost, right? That's what I did wrong. See, here's profit. Profit looks like this, right? They never cross. Not over here. They would cross over here. So my math is correct, but I'm using the wrong formula. I'm putting profit instead of cost here. So let's try that again. All right, so revenue is, well, instead of revenue minus cost, let's just set profit equal to 0. Profit is 0, means 0.086 minus 0.7 is 0. They gave us the profit function. All we have to do is set it equal to 0, right? Does it make sense? Where I screwed up and how I caught it, right? If I was in a hurry, I'd have just put a negative number down and been like, oh well, right? You can't have negative units. It doesn't make any sense. So this is easy. We just go move the 0.7 over here. Now divide both sides by 0.086. So 0.7 divided by 0.086 is 8.139 or whatever. So 8 units, rounding down. Oh, they want us to round to the nearest thousandth. Okay, fine. 8.139, so they don't want us to round. 139, actually this is a 5. So that would turn 5. All right, so if we're rounding to the tens, hundreds, thousandths, right? The 5 turns the 9 into a 0, so this would be 8.140, and you'd have to have that 0 there. This is one of the complicated rounding ones, right? Because the 5 turns the 9 into a 10, the 10 would turn the 3 into a 4, but you have to put the 0 here. 8.14 is not the same as 8.140. They're not the same thing. Numerically, they are, but this one has more information in it, right? Everything in math is a number, but the representation of the number has more or less information. They convey different things, right? All right. This tells you that you rounded from over here, right? This tells you that this is rounded from the thousandths, right? This tells you it was rounded from here, right? This tells you that this number was less than 5. This 0 tells you that the number over here was bigger than 5, and that this number used to be a 9, okay? So you would have to have that 0 there, otherwise you're going to get it wrong. Does that make sense? I'm rounding this. Y'all remember rounding? Most of the time it's pretty easy, but this is the one where it's funky, where that 0 matters, okay? Y'all all got that? Yeah, let's look at some examples. Let's say I have this, and let's say I have a different number. Break even. The break even point occurs when the profit is 0, right? Think about it, it's like when you start selling stuff, it's like you start off with a bunch of costs, right? Like you have to build your manufacturing plant or whatever. So at the beginning of your business, you're basically catching up. You know, it's like you're selling stuff, but you're still paying off your costs. So you get revenue coming in, but you still have all these costs to pay off. And so once you finally paid off the costs, that's when your revenue and your costs are the same, right? That's when your profit finally is 0. Because before that, your profit is negative. Your profit's negative until your costs are paid off. So once they go to 0, it's like boom. After that, you can start expecting to have profit, right? Does that make sense? And that's assuming that you start off with costs. You know, not all businesses are like that. You know, some of them you start off making money, but eventually you've sold so many that the price has gone down where you're not making money anymore. So you could start off with a positive profit, sell so much, and then end up making negative if you keep selling them. Does that make sense? The two different situations, right? Most times you have like a cost, an initial cost, and then you have to sell a bunch of stuff to pay it off. All right, but everybody's got the rounding down here. All right, so we have time for one more, all right? And oh, all right. All right, y'all should all work these problems and prepare because the exam's in class, so you're limited on time, right? You don't want to have anxiety slowing you down, right? It's all the little subtlety things. Like you might think you know the math, but being able to do the math quickly without screwing up the little things is the hard part for an exam. Find the equilibrium quantity, all right, and equilibrium price for the commodity whose supply and demand functions. So here's supply, here's demand, all right? So Q stands for quantity, okay? So these I find complicated because these are two different price functions, right? And they're kind of backwards as far as I'm concerned. You'd think like the price, if demand goes up, right, the price should go up, right? But that's from the point of view from like the customer, right? If you turn this thing around and think of it the other way, it's like um, if the if the price is high, right, suppliers don't want to have to make it because it's too expensive. See what I mean? So depending on how you interpret it, it can have the reverse uh, intuition. Okay, depending on if you're looking at it from the manufacturer's point of view or from the seller's point of view or from the customer's point of view. We're used to looking at things from the customer's point of view, but when you reverse things, it can be different, right? So like the price here, if you graph this price and supply, right, it's going up. So as the supply goes up, the price goes up. That doesn't make sense from a consumer point of view, right? Because if there's a whole bunch of them, shouldn't the price go down, right? But from a manufacturer's point of view, right, if the price is up, they want to make more, right? I said it wrong the first time. I told you it's complicated, right? Took me a while to understand. It's like, well, if the supply is going up, why is the price going up? It seems like it should go down, right? But no, if the price is high, that's motivation to make more of them, right? To create more because you could sell them at a high price. Does it make sense how the interpretation is flip-flopped? Okay. So the equilibrium quantity, that's where supply equals demand. So you set P equal to P, right? So we had to have 60Q equal to negative Q squared plus 7,200. All right, so this is just a polynomial, right? If we move everything to one side, move this over, we have this, and then this. So move everything over, right? And then either you could try to factor this dude, or you could just use the quadratic formula, right? Quadratic formula says negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? And this guy, the minus here, that's going to give you a negative quantity. So you're going to end up using the positive there. So just plug that in. All right, once you know what your Q is, this is some number, some equilibrium quantity. We need to know what the price is. Just plug that in. You can plug it into either one of these. They're going to give you the same price, right? Because that's how we found it. We set those equal to one another. You plug it into either one of those, and then you get your equilibrium price. Got it? All right, let's get the hell out of here. See y'all Wednesday. Do your homework and stuff.